See, last lecture we have discussed what is dot product and a cross product, or a scalar product and a vector product, correct? We have defined that a dot product A dot B is equal to AB cos theta, correct? But when we spoke about what is called as your vector product, we did say that A cross B is equal to n cap magnitude of A, magnitude of B into sine of the angle between the two vectors, correct? We did mention that suppose we have one vector like this, the other vector like this, vector A, vector B, angle between them is theta, then this part, okay, this is n cap unit vector, and this gives me vector C is equal to A cross B, correct? A simple logic. So sine theta, what is theta lies between? Theta lies between 0 less than equal to theta less than equal to pi, correct? But if we take exactly opposite, correct? This is what the curled finger are given a direction from A to B. So at that time thumb will give a direction of A cross B. But when we say exactly opposite, so that time I can draw like this. This is my n cap and this is my A cross B, which is vectors, right? Exactly opposite. So when the curled finger from B to A, that time I am going to get, my thumb will give me A cross B in a minus direction. Which means very clearly that A cross B is not same as B cross A. Which means vector product does not obey commutative law of multiplication. Very sorry. So over here now, as we know theta lies between 0 and pi, we have to define the characteristic immediately. For example, what I mean to say that if my theta angle characteristic of vector product correct, if I say that the two vectors are parallel to each other, vector A and vector B are parallel to each other, so sine theta will be 0. What is sine 0? This is my sine angle, 0, pi and 2 pi. Perfect. So when I say that A and B are parallel to each other, angle will be 0. So I can say that A cross B will be 0 when the two vectors are parallel to each other. Theta is 0 degrees. So that time I get A cross B is equal to 0. From this expression we can say that even A cross A will be 0. A vector product with itself will also give me 0 value. Like in case of dot, we got the value 1, but in case of cross product, I am getting the value to be 0. Okay, this will help me out to define important characteristic. Which one? Suppose I say I cross I. What is I? A unit vector. So I cross I will be in this fashion, will be 0. What is I now? A unit vector along x-axis. Correct? Same way, what is j cross j? What is j? Unit vector along y-axis. What is k? Unit vector along z-axis. So I can say I dot I is equal to 0. Same with j dot j is equal to 0, or k cross k is equal to 0. Correct? In case of dot, I dot I was 1, j dot j was 1, k dot k was 1, but here it's not so. But at the same time, if at all I try and say that when the two vectors are perpendicular to each other, correct? When the two vectors are perpendicular to each other, which means 90 degrees. What is sine 90? Will be 1, correct? So at that time, what will I say? A cross B, correct? That time A cross B will be n cap AB. Why? Because sine 90 will be 1. So n cap AB. AB will be, n cap is unit vector along that this, as I mentioned earlier. This is suppose A vector, this is B vector, this is n cap, and this is C is equal to A cross B. Understood? So if it is so, how this will help me? This will help me, the magnitude of A cross B will be A into B, magnitude of vector A and vector B, correct? This will help me out to prove I cross J. I cross I is 0, but I cross J will not be 0, will be K, correct? In the same way, J cross K will be I and K cross I will be J. This is very important properties. Similarly, if at all I change the order, which means instead of I cross J, suppose I say J cross I, correct? It will be minus K. If I say K cross J, it will be minus I, and if I say I cross K, it will be minus J. So these are the very important characteristics of the vector product. This will help us out in deriving the expression for A cross B also, correct? So we'll use them to define our next relation, which is vector product in terms of its magnitude of the vectors. So I'll say A cross B is equal to IAX plus JAY plus KAZ IBX plus JBY plus KBZ, correct? Now cross product over here, not dot, cross product. So what I'm going to get, IAX cross IBX, IAX cross JBY, IAX cross KBZ, using this. So what is I cross I first? 0, already we have seen that. I cross I 0, J cross J 0, and K cross K 0. So first term I cross I will be 0. So I'll write I cross I AX BX plus I cross J AX BY plus I cross K AX BZ, correct? Unit vectors plus now the second term. So J cross I AYBX plus J cross J AYBY plus J cross K AYBZ. Check the terms clearly. Now the third, K with this. So K cross I AZBX plus K cross J AZBY plus K cross K AZBZ, correct? Using I cross I 0, J cross J 0, K cross K 0, because A cross A 0, correct? So I'll cancel this term, cancel this term. Now remaining term, what is I cross J? It's K. So I'll write K AXBY This is I cross k. What is I cross k? It's minus j. So minus j ax bz. This is plus term, this is minus term. Then what is j cross I? Minus k. So minus k ay bx. What is j cross k? It's I. So plus I ay bz. Then the k cross I is how much? Plus j az bx. What is k cross j? It's minus I az by. Now try to connect the terms together, which will help me out to get what is called as the terms in fashion. So here, as far as I is concerned, I have two terms. I'll collect the I terms first. So I ay bz minus az by. This term I and this term I. Now j, I have one term here and the other term here. So I'll write plus term. Plus j az bx minus ax bz. Correct? Plus k. I'll write the plus k. Plus term first. So plus k inside the bracket ax by minus ay bx. Correct? So I use this to get my all these terms ready. This is nothing but what? Nothing but a cross b is equal to I, j, k, the unit vectors. Correct? Second bracket I have ax, ay, az. Here I have bx, by, bz. Correct? How we do it? We always do it I into ay bz minus az by plus j. If it is plus j, I have to take this term first. Az bx minus ax bz and plus k ax by minus ay bx. So this is the simplest way of doing vector product in terms of the magnitude of the vectors. That is, vector a is iax plus jay plus kaz, and same way even the vector b can be written and you get such simple explanation. Correct? Next we'll say that which laws this vector product obeys. We have just shown now that a cross b is not same as b cross a, because where minus sign is concerned and b cross a is concerned, because it is going minus direction, which means a cross b is equal to minus b cross a, or a cross b is not equal to b cross a, means does not obey the commutative law of multiplication. The first one. Next one, first law is a cross b is equal to minus b cross a. This is commutative law of multiplication. Correct? Next one is a cross b plus c. Here I have suppose three vectors, vector a, b and c, and vector product with b plus c. You get a cross b plus a cross c. First a with product with b and then with product with c. This is called as what? The vector product of two vectors obey distributive law of multiplication. And the third one, suppose I have a scalar m which is applied on a vector product. M with vector product of a and b gives you the different choices, which is m a cross b, or it gives you a simple logic called as a cross mb, or a cross b outside the bracket m. So the m scalar, either it will be with a vector cross product with b, or it's with b vector cross product with a, or it's a cross b, then you have a scalar m. So anyway, you can use this in short. Correct? Next one. This is called as the modulus of A cross B in short is called as modulus of A cross B is called mod of A cross B gives you area of parallelogram with both vectors or both sides A and B. Correct? Next. So definition, area of parallelogram is equal to base into height. Correct? Simple definition. So here we can use base will be A, height will be h, and that will be nothing but b sine theta. This we will show you also. So here suppose I show a very simple diagram as far as vector A over here, then here I have vector B. Correct? Simple diagram. Then I try and drop a perpendicular over here. This is my h, and I try to combine this to get the parallelogram in short. So this will give me what is called as PQOP. This is OPQR. Right? So over here, this is my h, height will be nothing but b sine theta. This is angle theta. So sides will be side A, base, B vectors over here, perpendicular will be h, will be b sine theta. So here I have my simple diagram like this. So this will give me nothing but the area of parallelogram with vectors A and B in this fashion. Correct? Now what is the example over here we can give? Example of this will be angular momentum L is equal to R cross P. This is angular momentum. Is equal to R cross P, which is R is position vector and P is the linear momentum. This is the position vector and P is my linear momentum. This is the first example. Second example, we can say that you have the force acting, correct, will be nothing but Q V cross B. Force V is velocity and B is my magnetic induction. So even this way we can try and write the second example also. Correct? So this finishes my vector product and scalar product. Correct? Next lecture we will try and do what is called as scalar triple product and then vector triple product, and then we'll take the lecture for the problems on all these topics together. Correct? So first job will be see this video carefully. So this will help you out in solving the problems also. Correct? Thank you.